I took a second to regroup. I had a number wrong here. So on your chart, please. I had it, I didn't have this 80 right. I had it as 20. Should have been 80. So if I start from here to here is 80, from here to here is 108, and from here to here is 150. So when you come from the ends to the center, this box right here should be half of the length of the curve, whether you come from this direction or whether you come from that direction, okay? So there's where my points are going to be. Now, the gradient elevation. This seems to be a problem child. Okay, I'll tell you how I do it. You can do it your way. I go out and then back. So let me show you what I do. I'm trying to get the elevations of the gradient at each of these points. So I'm going to go through and plot these little points quick, okay? So we've got them. So I'm going to have one right in here somewhere. Give me green this time. Let's go 20 feet. Right there somewhere. And then I'm going to have one out here somewhere. And then I've got this guy right here. And then I've got one right here. And then I've got one right in there. So this guy right here is 29 plus 0, 0. This guy right here is 30 plus 0, 0. This guy right here is 30 plus 30. This guy right here is 30 plus 72. This guy here is 31 plus 0, 0. And this guy here is 31 plus 80. And this guy right here is 28 plus 80. Okay, so there's my stakes. When I get done, I'm going to stake this out. I have one right here, one here, one here, one at the low point, one at 31, and one at 31.80. And that should be the feet. 20 foot here, 100 foot there, 30 foot there, this way, 80 foot there, 28 foot there, 42 foot here. That looks pretty good. I like that. Okay, now what I need to do is I need to get the gradient directly underneath there. So right here. I need to get the gradient because using the formula for parabola, if I know that gradient, I can do a little bit of simple math and end up with a curve elevation. So I need one there, 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 need one there. And hopefully you can see the curve elevation and the gradient elevation at the ends are the same. So let's do it. I'll tell you how I do it. I'm going to write the one I've got down. I've already got this one. PVI is 46592. That was given. Okay? Okay, I go uphill, then I come back down. So here's how I do. I go 465.92 going at 3 feet per 100. If I go 100 feet, what's my elevation there? That's what it looks like in my calculator. 465.92 plus 0.032 times 150. 470.72. I write it down. Then I go to the other end and do the same thing. I start here, I go uphill at 1.8 feet per 100. So I put in there 465.92 plus 0.018 times 150, and I get 468.62. Okay, now I start back downhill. I'm at 470, I go downhill, so I'm doing this. Okay, I'm just going downhill. So I take 470.72 times, or minus 470.72 minus 0.032 times 20 feet. 470.08. Then I do the same thing again. I take the 470.72 minus 0.032 times 100 feet, 120 feet times 120. 46688. Then I check and make sure I've done things right. I put 470.72 minus 0.032 times 150 feet, and I get 465.92 is exactly what I wanted. Now I go the other way, and I do this. Okay? So I'm just coming off of a line and going down to the point. So I start out with 468.62 minus 0.018 times 80 feet. Same thing, 468.62 minus 0.018 times 108 feet. Then I do one more to make sure I didn't screw things up. 468.62 minus 0.018 times 150 feet. 465.92, exactly right. Now I got my gradient elevation. So I got an elevation right here, here, given this, here, here, and there. So I'm going to write those down. I can get rid of this guy now, I believe. And I can get rid of this guy. And I can write 470.08. I can write 466.88. I was given that one, so that's good. Then I can come around the corner. I can write 466.676. 466.676. Next one is 467.82. That one I already wrote down. So there's my gradient. Okay, once I have the gradient, then I've got a formula that will allow me to calculate this distance right here. That distance is y. Okay, there's y. What does y equal? Y equals rx squared. Where's x? Right here. Where's r? R you have to figure, okay? It's in your book. I'll tell you what page you need to go to. You need to go to page 1713, and it says G1 minus G2 over 2L. So R is equal to G1 minus G2 over 2L. 0.032, 0.018. Now this you got to carry out quite a few places. If you round it off, you got yourself in a mess. So I'm going to take those two, divide it by 600, minus, there's the number I get. 4 zeros, 8, and a bunch of 3s. Okay, I store that, and then I just multiply it, okay? So, needless to say, if this is x, the first one's 0 because x is 0. The last one's 0 because x is 0. So the curve and the gradient have exactly the same elevation. The rest of them, I got to do the math. So I'll take that, x is 20 squared times 20 squared. 120 squared. 150 squared. $108 squared. $80 squared. So y is the difference between the gradient and the curve. Okay, what do I do with it? Students say, do I add or subtract? Look at the picture, it tells you. I've got an elevation here, I want to get up to here, and y is this dimension. How do I get up? I add. So don't worry about the signs, use your head. So all I got to do is add these together. So this is 470.11. This is 468.08. Okay, let's make sure I'm doing this right. 0.88 plus 1.2 is 468.08. That's good. 465.92 plus 1.875. Uh, 466.676 plus 0.97. And 467.82 plus 0.53. Okay, there's your curve elevations. Does it make sense to you? Is this, in fact, this is the low point line right here. That's the low point line. Is it? Is there any elevations in that whole list that are less than this? 67.95? No. No. All the rest are bigger. Makes sense. So those are the elevations at these points right here. 1, 2, 3, 4, 5, 6, 7. And that's it. Okay? Now we may have some grade running through here, and I'm going to do that in the next little presentation. I may have some grade running through here, okay? This may be in a piece of property, and let's say that the elevation comes through here like this. Okay, when I put my stake in the ground, it's going to be on the ground. It's not going to be down underneath the ground. So I'm going to have a stake right here, one here, one here, one here, one here. Okay, if I look at those stakes and I look at where the grade has to be, and the next thing what we're going to do is say, how do I tell the guy in the field that the stake is above the ground, but I want you down here? Okay, we use what we call cut-fill stakes. We'll put a line on the stake that will tell the person to cut, go down, or fill, go up from that line to get to the finished grade. So hopefully that helps you. I don't know if this is exactly the way you had it in your head, but I think it works fairly easily. You got two equations you better get your hands around. One is the position of the high-low point, that's that. And the other is the development of an R value, which is this. Other than that, understand what y is. Hopefully you understand Rx squared is a parabolic equation. So I'm looking for a little y. That's the distance between the curve and the gradient line. Students tend to have problems getting these gradient elevations. And then they want to round this off to 2 places and find out the number doesn't change ever. You got to carry it out, okay? That should do it. Good luck.